Hello again, and welcome to another math episode of Learning in the Closet. So let's go ahead and go to the forces thing for this week. We have one force of 6.4 pounds and one force of 1.4 pounds act on a body at the same point so that the resultant force is 7.1 pounds. Now, what does that look like? That's going to be our first question. Because whenever we can draw something, it's a lot easier to come up with what that means. That means we got a 6.4 going here, and we've got a 1.4 going here, such that the resultant, as in when you would make a parallelogram out of them, like so, this diagonal here that I'm making in blue is going to be 7.1. We want to find the angle between them right here. And the way that we are going to do that is we have all three sides of a triangle, because each line that has the same color as another line is not only parallel, but the same length as well. So it's a parallelogram, and we have from it these triangles. Now, what we want to actually do with these triangles is simple. We want to go ahead and find the angles given the sides. And real quick, I'm going to head over to here, and given that law of cosines thing, now that we're here, we're going to go ahead and solve for that angle by saying it is going to be, we're going to want the angle opposite the 7.1 first. So we're going to want the corner angle where the red and the green meet. So that's going to be a squared, which is 6.4 squared, plus b squared, minus c squared, over, I believe it's 2ab. So that's going to be 1.4, 1.4. And that is going to be equal to cosine c. And c is the angle we're looking for. So we're just going to inverse cosine this. We get a 114.7 degree angle. And we just want to take that away from 180 to get the other one in the corner. So that will be 180 minus all this. And that's 65.3 degrees. And apparently I appear to have made a mistake. Yes. So the mistake that I made was I didn't read the end of the problem. I found the angle in the corner here. Well, it's the same as the angle here. I found the whole angle there instead of finding the angle between the resultant and the larger force like we were asked to. So, had I been a better student a moment ago, I would have replaced in our calculation the 7.1 with the 1.4. And that gives us this. Yeah, it apparently is going to give us a very different angle. Simply 1.7 with 4 zeros degrees. Let's see if that works a little better for us. It doesn't. What in the world did I just do? I'm going to pause, I guess. Okay, so I have found my mistake, and it is not a math mistake, but a typo. I had a 7.2 here, which made it into 1.7, whereas a 7.1, which is what I meant to type, would have given me 10.3 degrees. So the math itself stacks up, but this can also serve as a lesson to be very careful about what you've actually typed down. Because when I had a 7.2 in my calculation, it gave me 1.7. When I have 7.1, like I actually meant to have, it gives me 10.3, which it tells me I was supposed to get. So let's try another one of these, and we'll see what we get. Okay, so these two forces act simultaneously, and the angle is 18 degrees. We want the magnitude of the resultant to the nearest Newton. So what we need is, given these two sides an angle, let's go ahead and use a little bit of our trig in order to solve this one. So we're going to do that by showing that, let me go ahead and screenshot, the angle between these two forces, this is very not drawn to scale, is 18 degrees. So we want the length of that line here. And we find that by simply applying law of cosines on this fella here. We know that this right here needs to be 180 minus the 18 degrees we started with, so that's 162. So what we're going to do is, since these are the same length, we've got 520 up here as well, and the 162 is an angle, so I'll give it degrees. What we want to do is find the length of the diagonal line that goes through the entire thing by simply using law of cosines on our side angle side. So we have that is equal to, I'm going to call it c. So c squared is a squared plus b squared minus 2ab cosine c. So that's going to end up being, calculator, I'm going to say square root of, I'll do it in a minute. So let's see, 640 squared plus 520 squared minus 2 times 640 times 520 times cosine of 162 is our angle. So we're going to just go ahead and paste that all into a square root. We get 1146, not 5, is our magnitude of our resultant. So the length of that diagonal line that we get. And it works great. So this will always put the larger force on the bottom. You don't have to, but it can be nice. It gives you a nice little squishy sideways parallelogram instead of a tall one. But yes, we now have law of cosines, and we use that to find x, and we're done. So we've done a couple of those, just kind of showing you how that works on the forces. Multi-step forces can be a little trickier, unfortunately, but we'll still survive. So we have two simultaneous forces, and we need to find the resultant and another part of the trigonometry behind it. So the first thing we're going to do again is we're just going to go ahead and take that screen grab. And that is going to give us 71, 31. The angle between them is 66 degrees. Now, what we want to do is find the magnitude of the resultant, which we can do the same way we just did the last problem by doing 180 minus that. And doing our law of cosines like we just did. So let's go ahead and just plug that straight in. 180 minus 66 is 114. So we're going to do 71 squared plus 31 squared minus 2 times 71 times 31 times cosine of 114. It's going to give us this, and we're going to want to take the square root of that to find the resultant, and that is going to be 88 so the nearest Newton is just 88. So that should be satisfying after what we just did. To find the angle between the resultant and the smaller force, we're going to need to do a similar calculation. We want this angle here between the resultant and the 31. So we know that's 88-ish, but we're going to keep the number fully precise in delta math for now. So in our calculations, and in the end, we'll just round with that. So now we can use, I believe, 1 second, let me take a quick look to make sure we're doing this right. Oh, yes, we know that this is also 71, so we can use law of sines to find the angle. Because the 88 divided by the sine of this thing should be 71 divided by the sine of the angle we're looking for. So 88 divided by the sine of 114 is going to be 71 divided by the sine of, I'm going to call it angle C. That's going to be what we're looking for. So in order to find C, we're going to go ahead and just divide 71 by everything on the left. So let's just cut that out here, paste it here. We got sine C equals this. So C should be the inverse sine of this entire monstrosity. And that, my friend, is going to give you 47.28, whatever. Tenth of a degree is going to be 47.3 degrees between the resultant and the smaller one. We nailed it. To double check, this continually asks for the same thing. It should work well for you. It'll take some rearranging to do the other stuff, and this will take you some time. Whenever you're confused, again, ask me for help, ask your classmates for help, go to the examples and videos on Delta Math if they're available and helpful for you, and don't be afraid to check YouTube. So yeah, have a good one, y'all. Just do your best, and when you get confused, don't get too overwhelmed. I get this stuff is hard, so I'll work with you here. Have a good one.